looking at compound interest. Now we'll use compound interest for saving money, borrowing money and investing money. That's when we will use the following formula. So the compound interest formula, F equals P by 1 plus I to the power of T. Now, this formula is found on page 30 of your log tables booklet. So I'll just show you that. Okay, so you'll see it in your log tables and it'll be just written as compound interest, and there's the formula. F equals P by 1 plus I to the power of time, T. Okay, so F represents the final value, or you could call it future value if you want. P represents the principal value at the very start. So if we're saving, it's the principal amount that you saved first. If you're borrowing money, it's the borrowing amount, the loan. If you're investing money, it's the original amount that you invested. Okay, that's what P stands for. I is the interest rate, and we will always express it as a decimal. So, if it's 4% as an interest rate, well, that's 0.04 as a decimal. If it was 2.5% as a percentage, that would be 0.025 as a decimal. To turn a percentage into a decimal, all you need to do is divide by 100, which means you just bring the decimal point, which would be here, 2 places left. Bring the decimal point 2 places left, and that's how you get your decimal equivalent. Calculator will do that for you as well. All right, so our interest rate, I, in the formula, is always going to be written in a decimal format. You can't just sub in a 4. You can't sub in 2.5. You have to write them as your decimal equivalents. And T represents, so that power up there, power of T, that represents time. And it's usually in years, unless the question kind of breaks everything down into months, okay, or weeks. But usually it's years. So that's our formula, which is in the log tables on page 30. And that's what all the variables represent. So F is the future value or the final value. P is the principal value at the very start of the time. I is your interest rate expressed as a decimal, and T is time, usually in years. Example 1. Mike invested €20,000 in a savings scheme that would earn him 2.4% compound interest per annum. Per annum means per year. So everything is in years, right? What is the value of his investment after 6 years? And give your answer to the nearest euro. So he is investing money here, and they use the word compounded. So if they use the word compound interest, I'll put down the formula for compound interest, and then I'll note what all the variables represent. Okay, so in the formula, it's F is the final value. That's what I'm looking for, because it says what's the value of his investment after 6 years. So that means find F, okay? So F, we don't know what that is. P is the principal amount that he invested, so P is 20 grand. I is my interest rate, which was 2.4%, but as a decimal, that's 0.024. And it's 6 years is the time frame, so T is 6. So I put down the compound interest formula, which is in the log tables, page 30, and we just sub into that formula. So it's F equals 20,000 by 1 plus the interest rate to the power of 6. Now, you can plug all of that into your calculator in one go. Okay, so that's what it will look like on your calculator. Press equals, and we get back €23,058.43009. Okay, and that's what I'm going to write down. The question did say give your answer to the nearest euro. So we'll look at the 4, the first digit after the decimal. That means the 8 is going to stay as it is. So I round down to €23,058. That is the approximate value then. So after 6 years, his €20,000 is now worth €23,058. So it has increased in value over time. Example 2. Tom borrowed 12,500 from Bank of Ireland. Okay, so now we are borrowing. So that's going to be my value for P. That's the amount he borrowed originally, the loan. The compound annual rate, the word compound tells me I'm going to be using the compound interest formula. So the compound annual rate was 4% for the first year. And then it would decrease by 1.5% thereafter. So there's going to be a change. For the first year, it's 4%. But after that, the next year, it's going to go down by 1.5%. It doesn't mean it's going down to 1.5%. It's going down by. All right. So 4% take away 1.5% would leave you at 2.5%. So the compound rate of interest for the second year would be 2.5%. Okay. if Tom repays €2,000 at the end of the first year, how much does he owe the bank at the end of the fourth year? Okay, so there's a couple of things going on in the question, so we're going to break it down. I'm going to do year one on its own. Why? Because the interest rate is different for year one than it is for year 2, 3, and 4. So I'm doing it for 4 years altogether, but they said after the first year, the interest rate went down. It reduced by 1.5%. So that means in year 2 and 3 and in year 4, it'll be a different interest rate than it was for year 1. So I have to do them separately. Okay, I'm going to label what everything is. Okay, and we're going to do year 1 first. So here's my compound interest formula. So for year 1, the final value would equal, he borrowed 12,500 multiplied by 1 plus the interest rate for year 1 was 0.04 as a decimal to the power of 1 year, because we're only doing it for year 1, so that's 1 full year. That gives me €13,000. That is the value of his loan at the end of the first year. So this is what he owes the bank. But they then said, if Tom repays €2,000 at the end of the first year, so I'm still in the first year, I'm at the end of it, but he's now going to repay €2,000 off of that figure. That means he now owes the bank €11,000 at the end of year 1. If he owes €11 to the bank at the end of year 1, he will still owe €11,000 to the bank at the very start of year 2. It doesn't suddenly disappear. Okay, so he will, going into year 2, this is now what he owes the bank. Remember what's happening. They said after the first year, the interest rate is going to decrease by 1.5%. So we now know that the interest rate has gone from 4% down to 2.5%, because 4 take away 1.5 will give you 2.5. And 2.5% as a decimal is 0.025. So for years 2, 3, and 4, the interest rate is going to be 0.025. Nothing else is happening after that, right? He's not repaying anything else, which means because nothing else is happening throughout the other 3 remaining years, I can do the 3 remaining years in one go, okay? Because they all have the same interest rate. If the interest rate changed again for, say, year 3 or year 4, you'd have to do them separately. But it's remaining at that interest rate for years 2, 3, and 4, so I'll do them all in one go. Okay, so year 2, 3, and 4, F equals, I'm using my compound interest formula. At the start of year 2, he still owes €11,000 to the bank. Okay, multiplied by 1 plus, the new interest rate was 0.025 as a decimal. And because we are doing it for years 2, 3, and 4 altogether, I'm doing it for 3 years in total. So a power of 3 on the bracket, and that's based on my formula. You can plug all of that into the calculator. Okay, press equals, and I get back €11,845.79688. And then I'm rounding it. Like, they didn't say what way to round it, but it is money. So I'd round it to 2 decimal places, which means I'll look at the 6. The 6 will mean the 9 has to round up to a 10. You can't write 10, so you put down a 0. Add a 1 onto the 7 and you get an 8. So €11,485.80. So at the end of year 4, this is now what he owes the bank. So he still owes them €11,845.80. And remember, what he had originally borrowed was 12,500. That accumulated interest in year 1, but then he made a repayment of €2,000 at the end of year 1, which meant he still owed 11,000 going into year 2. So then from year 2, 3, and 4, he owed 2.5% interest for each of those years, and he wasn't making any further repayments. So this is the full amount that he owes the bank at the end of the 4th year. And who knows, maybe he'll be able to repay it at the end of the 4th year. Maybe he won the lotto. Example 3. Joan saved 12 grand in the bank for 3 years. So now we're saving again. So that's the original amount she saved. So that's P. 3 years, so that would be T. At the end of the 3rd year, the value of her savings amounted to this figure. So that's the future value of what she originally invested. That was the value for P, which means that must be F, if that's what it amounted to after 3 years of saving. What was the compound interest rate per annum? So per annum means per year. So what was the yearly interest rate? That means find I. Okay, so I just label what everything is. P is 12,000, T is 3, F is the 13,000 figure, and they said find the compound interest rate. That means find I. So I will put down the compound interest formula. I'm going to sub in what I know into that formula. Okay, so that's everything I know so far. So the only unknown in the equation is I. Okay? So if you eventually want to solve for I, but I is trapped inside the bracket is then cubed. Okay, it's put to the power of 3. And then it's being multiplied by 12,000 in order to get this figure over here. I'm going to undo all of that. So the first thing I'm going to do is I need to get rid of the number that's in front of the bracket first. I can't get rid of the power until I've gotten rid of this number first. So in order to get rid of it, it's being multiplied currently. 12,000 is being multiplied by the bracket. So I need to divide by 12,000. And what you do on one side of the equation, you do to the other. So we divide both sides by 12,000. Then this 12,000 will divide into this 12,000, so it's gone. And if you plug this into the calculator, €13,891.50 divided by 12,000, I will get 1.157625. That equals the 12s divided into each other, so you're just left with the bracket to the power of 3. Okay? Now, I still want to get what I is. I is trapped inside the bracket, and the bracket is being put to the power of 3. So we need to get the bracket without a power of 3. So I need to undo a power of 3. The opposite action of cubing something would be to get the cube root of it. That's like saying the opposite action of squaring something is the square root of. Okay, so just for example, if I have x squared, if I square root it, a square root cancels out a square, and you'd actually just be left with x. So if I had x cubed, the opposite action of cubing something is to cube root it. A cube root cancels out a cube, and you would just be left with x. If I had x to the power of 4, and I want to undo that, if you get the fourth root of x to the power of 4, a fourth root cancels out a power of 4, and you would just be left with x. Okay? So that's what I mean here when I want to undo a power of 3, because I want to get 1 plus I on its own. But currently it's trapped inside the bracket and it's to the power of 3. To undo that, I'm going to get the cube root of both sides. What you do to one side, you must do to the other. So the cube root of this bracket cubed, a cube root cancels out a power of 3, so you're just going to be left with 1 plus I. You can then put this into your calculator. So the cube root of 1.157625 equals 1.05 as a decimal. Okay, so now I have 1 plus I is equivalent to 1.05, and I want to get I on its own. So bring the 1 over and subtract it. 1.05 take away 1 leaves you with 0.05. That is now your interest rate as a decimal. But when they asked what was the compound interest rate per annum, that means if they want a compound interest rate, they want a percentage. I have it as a decimal. To turn anything into a percentage, you just multiply that by 100. And that will give you 5%. So my compound interest rate per annum must have been 5%. Now you can obviously check if that's correct by subbing it back in here. Okay, so it would have been 12,000, a bracket 1 plus 0.05 to the power of 3. And if you plug that into your calculator, you will get back €13,891.50. Okay, so 12,000 multiplied by 1 plus my interest rate as a decimal, which is 0.05 to the power of 3. And I get back €13,891.50, which is what they said it should be. So I know my interest rate is correct. Okay. And always remember, if they had asked you to do rounding in the question for the rate, now look, it came out to be 5% exactly, but let's say it didn't come out to be an exact, you will always convert something into a percentage first before ever you would go rounding. So you'd never round at this stage. You'd always turn it into a percentage first and round afterwards if you had to round at all. Okay, I want you to pause the video and go and try the following one yourself. Then come back and watch the solution afterwards. Okay, Paul saved 8,500 in the bank for 2 years. So that's going to be my value for P. All right. Now, time is 2 years initially. At the end of the second year, the value of his savings amounted to €8,930.31. That's F. If that's what his investment amounted to. That was the final value. What was the compound interest rate per annum? And give your answer to one decimal place. Okay, well, it's compound interest, so I'm going to put down the formula for compound interest. P is 8,500, time is 2, F is 8,931, and I do not know I. So I will be the only unknown in the question. Okay, so now we're subbing into the formula for compound interest. So it's going to be €8,930.31 is equal to 8,500 multiplied by 1 plus I, the interest rate, to the power of 2 years. Okay, I eventually want to solve for I. I is trapped in the bracket was squared, and then it got multiplied by 8,500 afterwards. So I need to undo all of that. I need to get rid of the 8,500 first. The opposite action of multiply is divide. So I need to divide by 8,500. What you do to one side of an equation, you do to the other. So I'm dividing across by 8,500. The 8,500 here will divide into the 8,500 above, so it's gone. 8,930.31 divided by 8,500 on the calculator will give you back this decimal. So that is now equal to the bracket squared. So remember, the two of those, they divide into each other once, so they're gone. So you're just left with 1 times the bracket, which is the bracket squared. Okay, I want to get I on its own. I is trapped in the bracket. The bracket is squared, so I need to undo a square. The opposite action of squaring something is to square root something. And what you do to one side, you have to do to the other side. So we square root both sides of our equation. A square root will cancel out a square. So then you will just be left with 1 plus I in the bracket. You can put all of this into your calculator and you'll get back this decimal. So 1 plus I is now equal to this big decimal. I want to get I on its own. So bring the 1 over and subtract it. And then you will get 0.024999857 is equal to I. Now that is your compound interest rate as a decimal. They said, what was the compound interest rate? That means I want it as a percentage first. And afterwards I will round it to 1 decimal place. So you don't go rounding now. You wait, turn it into a percentage first by multiplying by 100. If you multiply it by 100, you're just bringing the decimal point 2 places to the right. So you get 2.4999857%. Now I'm going to go rounding it. They said give your answer to 1 decimal place. So I'm going to look at the 9, which is the second digit after the decimal point. The 9 will mean the 4 has to round up to a 5. So my interest rate per annum is approximately 2.5%. Now, when you want to check that answer, you can't use your rounded figure to check. You'd actually have to use the unrounded figure to check. Okay, so I would be subbing in my interest rate as a decimal, this figure here. I'd be subbing that in to my formula. So it'll be 8,500 to bracket 1 plus that decimal to the power of 2, and C will give you back 8,930.31, and it will. So 8,500 a bracket 1 plus the big long decimal for your interest rate before you went rounding it to the power of 2 years equals €8,930.31. So I know that my interest rate is correct. Okay, so that is the correct answer. If they ask you to verify your answer, you obviously have to write it all down on paper. But what I did on the calculator is what I'm writing on paper. So it's just checking your answer, subbing it back in to see will you actually get out what it should be. And when you're subbing in, you'd have to sub in the non-rounded interest rate as a decimal, not the rounded interest rate. You wouldn't get out the correct answer if you subbed in the rounded value. Okay, I now want you to pause the video, go and do the following questions. Okay, now there's more, right? There's those 3 questions as well. So go back, pause the video, go and do those questions, and when you have all of those 8 questions done, come back and self-correct from the video. Okay, question 9. Again, I'm using my compound interest formula. €1,500 was invested for 2 years at a compound interest. The rate for the first year was 3%, and then the rate for the second year was 4%. So the fact that the first year had a different interest rate to the second year, I'll have to do them separately. Find the total amount at the end of the 2 years. Okay, so that's my value for P. So I'm going to have to do year 1 on its own. So year 1, use your formula, sub in. It's going to be F equals 1,500 by 1 plus the interest rate for year 1 was 3% as a decimal, 0.03, to the power of 1 year because I'm only doing it for year 1. That gives you €1,545 at the end of year 1. So that means going into the start of year 2, that will now be your value for P. So in year 2, my new value for P, that's what I start off with at the beginning of year 2, multiplied by 1 plus the new interest rate was 4%, that's 0.04, and I'm only doing it for year 2, which means I'm doing it for 1 full year. And I will get back €1,606.80. That is the final amount, the final value of my investment at the end of the second year. Question 11. 700 will amount to €756 after 1 year invested at 8% per annum. By what number was 700 multiplied by in order to get 756? Well, you didn't just multiply it by 8%, because if you multiply 700 by 8%, all you will get is €56, which is the interest amount. In order to turn €700 into €756, you must have multiplied by 1 plus the interest rate. So 1 plus the interest rate is going to be 1.08. You can check if that's correct. 700 multiplied by 1 plus the interest rate will automatically give you back 756. So that's how I figure out what number did I multiply 700 by to get 756. Then by what number is 756 divided by to get 700? Well, sure, it's divided by 1.08 to get back 700. Check it on the calculator and you'll get it out. Question 12. A sum of money was invested at 7% per annum. If it amounts to 6,848 after 1 year, then find the sum that was invested. That means P was the amount that was invested. So find P. That means if that's what it amounts to after 1 year, that's F. Okay, so we've labelled everything. Put down the formula and sub into it. 6,848 is F. That should equal P, I don't know. Multiplied by 1 plus my interest rate was 7% as a decimal, and I'm only doing it for 1 year, so it's a power of 1. The power of 1 on the bracket doesn't change anything. So you can put it in or you don't have to put it in. It doesn't matter. It won't change it. 1 plus 0.07 is just 1.07 if you tidy it up. I want to get P on its own. P was being multiplied by 1.07. So in order to undo that, I have to divide by 1.07. What you do on one side, you do to the other side to keep it balanced. The 1.07 will divide into the 1.07 above and below. They're gone. You're left then with P times 1, which is just P, and 6,848 divided by 1.07 leaves you with €6,400. So that must have been the sum of money that was invested at 7% per annum for it to amount to this amount after 1 year. You can check if that's correct by subbing your 6,400 into your compound interest formula. So F would equal 6,400 multiplied by 1 plus your interest rate, which was 7%, and it's to the power of 1 year, equals €6,848. So I now know that my value for P must be correct. 14. What sum of money invested for 3 years at 8% compound interest would amount to €1,007.77? Okay, so T is 3, the interest rate is 0.08, and if it amounts to this figure, then that figure is F, which means I don't know what P is. So I put down the formula and I sub in what they gave me. You can tidy that up next. So 1 plus 0.08 would be 1.08. I can tidy it up further, right? 1.08 cubed. If you put that into the calculator, you'll get back 1.259712. Okay, so there's 1.08 cubed on the calculator. So that's where I'm getting that figure from. Okay, so it's 1.2597712 multiplied by P equals that. If I want to get P on its own, I need to divide by that figure. What you do to one side of an equation, you have to do to both sides. The 1.25 figure will divide into the 1.25 figure above and below, so they're gone. So then you're just left with 1 times P, which is P. And if you put this into the calculator, 1007.77 divided by 1.2597712, you'll get back this figure. Now it's money, so when they want to know what sum of money must have been invested, well, if you round that to 2 decimal places, you'd look at the third zero, which means the previous zero stays as it is, so it's just going to be €800, approximately. So that must be the amount I invested in order for it to turn into €1,007.77 after 3 years. Question 15. What sum of money was invested at 5% per annum compound interest? if it amounted to €10,988.76 after 6 years. Okay, so again, what sum of money was invested? That means what's P? The interest rate is 0.05 as a decimal. F is the final value, which was €10,988.78, and 6 is T. So I sub into my compound interest formula. 1 plus 0.05 is just going to be 1.05. If I put that to the power of 6 on the calculator, I'll get back this decimal. Okay, so you're just using the power button on your calculator, which is this one here. Some calculators you might have to press Shift and then that button to get it up, all right? And then put in your little power of 6. So now P is being multiplied by this decimal, and it all equals the 10,988.78 figure. If I want to get P on its own, I need to undo the multiplication, so I'm going to have to divide both sides by the 1.340095,641. What you do to one side of the equation, you do to the other. The 1.34 will divide into the 1.34, so it's gone. So you're left with 1 times P, which is P. And if you put that fraction into the calculator, you'll get back 8,199.996, which is our value for P. Round it to 2 decimal places, which means you'll look at the 6. 6 will mean the 9 has to turn into a 10. You can't write 10, so you turn it into a 0. You add a 1 onto the next 9, which is also a 10. You can't write 10, so you put down another 0 and you add a 1 onto the next 9. And it keeps going in that order until you eventually have it rounded to €8,200. So that must be the sum of money that I invested at 5% interest for 6 years, and it amounted to €10,988.78. When you are checking your answer, you'd always have to check using the unrounded figure. So the 8,199.996, whatever the rest of it was. Okay, you'd have to check with the unrounded figure, subbing it in. So that's question 15. 17. A person borrows 15 grand for 2 years. So P is 15,000, T is 2. Interest for the first year, T won't be 2 because it's they're changing the interest rates. Okay, right. Interest for the first year was 12%. The person then repays 6 grand at the end of the first year. Okay, so they're doing something in the first year, which means I have to do the first year separate to the second year. If the amount owed at the end of the second year was €12,042, then what was the rate of interest for year 2 for the second year? Okay, we'll do it bit by bit. I'll do year 1 on its own first using my compound interest formula. Okay, so I borrowed 15 grand at 12% interest, and that's for year 1, which is just a power of 1 year. That'll give me back 16,800. That's what I owe the bank at the end of the first year. But they're now telling me that at the end of that first year, the person's going to repay 6 grand off of that figure. So I'll subtract 6 grand, which means now, at the end of year 1, they only owe the bank €10,800. If that's how much they owe the bank at the end of the first year, that is the same amount of money they will still owe the bank at the very beginning of the second year. It then says, if the amount that is owed at the end of the second year is €12,042, what rate of interest was charged? Okay, so this is what they owed at the start of year 2. This is what they owe at the end of year 2. So obviously the difference between those two figures must be the amount of interest that accumulated. Okay, so I can use my formula. Sub in what I know. The final value at the end of year 2 was €12,042. The principal amount that I owed at the start of year 2 was €10,800. Multiplied by 1 plus I do not know. That's what I'm trying to find. And it's just for year 2, which is a power of 1 year. Okay, I eventually want to solve for I. I is trapped inside the bracket. Now, the bracket to the power of 1 doesn't change it at all. So you could ignore the power of 1 if you want. Then it's being multiplied by 10,800. So I need to undo that. So I divide across by 10,800. The 10,800s divide into each other once, so they're gone. 12,042 divided by 10,800 will give you 1.115. And that is now equal to the bracket, which was 1 plus I. Bring over the 1 and subtract it, and you will get I on its own. I then equals 0.115. Now remember, they asked for a rate of interest. A rate is a percentage. I have my interest as a decimal. Turn it into a percentage by multiplying it by 100, which means just move the decimal point 2 places to the right if you multiply by 100, and you'll get 11.5%. So in year 2, the interest rate was 11.5%. Whereas in year 1, it was 12%. So the interest rate dropped in the second year and it went down to 11.5% instead. You can check if that's correct. You'll use your decimal interest rate of 0.115. You can sub it in here to see will you get back 12,042, and you will. €12,042. So I know my interest rate is correct. Now, alternatively, I suppose the fact that at the start of year 2, this is what you owed, and at the end of year 2, this is what you owed. That means the difference between the two would be the interest that accumulated over that second year. So over a period of 1 year, which is the second year, the difference there is €1,242. Sorry, €1,242. So that must be the interest that accumulated in year 2 that you owe the bank. So if I want to express the interest as a percentage of what you originally owed, and I originally owed 10,800 at the start of year 2, because I'm only doing it for year 2. So to express it as a percentage, you could put the interest amount all over the original amount at the start of year 2, and to turn anything into a percentage, multiply it by 100/1. That will also give you back 11.5%. So you could do it that way as well, but you can only do it that way because it is just for 1 year. It's for all of year 2, which is just 1 year. If it was for several years all in one go, you could not do this method. You would have to do the compound interest formula method instead, which means you could only do this method. Okay? Question 19. A person invested 10 grand in a building society. The rate for the first year was 2.5%. At the end of the first year, they invested more money, €1,000. The rate for the interest or for the second year was 2%. Calculate the value of the investment at the end of the second year. Okay, so I'm going to have to do it year by year because they're changing the interest rates. So for year 1, using compound interest, 10,000 multiplied by 1 plus your interest rate as a decimal, which is 0.025, okay, 2.5%. That gives you, at the end of year 1, this is the value of your investment, but then they said they invested another €1,000, so add on 1,000 onto that, which means at the end of year 1, this is how much you have in your investment account now. At the start then of year 2, so if this is what it's at the end of year 1, that's what you have going into the start of year 2. But in year 2, the interest rate was now 2%. And I want to know what's the value of my investment at the end of the second year. So now I'm going to do it for year 2. I put down my compound interest formula and I sub into it. At the start of year 2, this is what I had, 11,250. Multiply by 1 plus 2% as a decimal is 0.02. And I'm putting that to a power of 1 year because it's all of year 2, which is just 1 year. That means at the end of year 2, this was the value of my investment, 11,475. It then says at the end of the second year, a further €2,000 was invested. So I'm going to add 2,000 onto that, which means at the very end of year 2, this is now the value of my investment, €13,475. If that's what it's valued at the end of year 2, then that's what it's valued at going into the start of year 3. It says at the end of the third year, the total value of the investment amounted to €14,014. So this is what it started off being valued at the start of year 3. This is what it finished up as at the end of year 3. And they've asked me to calculate the rate of interest for the third year. So for one final year, calculate the rate of interest. So I put down my formula and I sub into the formula what I know. The final value at the end of year 3 was €14,014 equals the principal value at the start of year 3 was the 13,475 multiplied by 1 plus the interest rate for year 3, which is I, to the power of 1 year because I'm only doing it for year 3. A power of 1 doesn't change anything, so I can ignore it. The bracket has the I in it. I want to eventually get I on its own. So I would get rid of what's in front of the bracket first. So I'm going to divide across by 13,475. The 13,475s divide into each other once, so they're gone. So now you're just left with the bracket, 1 plus I, is now equal to 14,014 divided by 13,475 will give you 1.04 as a decimal. Bring over the 1 and subtract it, and you will get 0.04 is now equal to I. They want an interest rate for the third year. So to turn anything into a rate, that means turning it into a percentage, just multiply it by 100. Bring the decimal point 2 places to the right, 4%. So your interest rate for year 3 was 4%. So remember, in year 1, it was 2.5%. In year 2, it went down to 2%. But for year 3, it has gone back up to 4%. You can check if that's correct by subbing in 0.04 as a decimal back in here to see, will you get back 14,014 euro? And you will. Okay, last question, 23. Aidan invests 5 grand in a special savings account for 2 years. The rate of interest for the first year is 3%, and then there's a higher rate for the second year. That means I have to do them year by year separately. Now, this time there's a tax involved in the question. Tax at 40% will be deducted each year from the interest that is earned. So they're not getting 40% on the value of the investment. They're just taxing the interest that is earned. So you're going to have to get the interest separately. Okay, how much will Aidan's investment be worth at the end of the first year after tax is paid? Okay, so we put down our compound interest formula. Now, the tax at 40%, right? When you tax somebody's interest that they have earned on their savings, that's dirt tax. So for any of you who do business, that's deposit interest retention tax, DIRT. It's a tax on the interest that you earn on a deposit account, so on your savings. Okay, in Ireland, it is currently 33%. In this question, it's 40%. The percentages can change. You know, any government budget can change the rate of dirt tax. Anyway, back to the question. How much would his investment be worth at the end of the first year? So I'm going to do it for year 1. If I want to calculate the tax that's going to be applied, you need to just calculate the interest first. So you're going to get 3% on the 5,000 that he saved. 3% on 5,000 is 150 euro interest. But he doesn't get to keep the full 150 euro because the government is going to tax him at 40%. So they're going to take 40% off of that, which means they're going to leave him with 60%. So the quickest way would be just to get 60% of that figure, which means he actually will get to keep 90 euro. Alternatively, get 40% of the savings amount, of the interest amount. That's 60 euro. That's the amount of tax they're going to remove. Take 60 euro off of the interest that he earned, which means the interest that he actually gets to keep. So the remaining interest is 90 euro. Okay. The question said, how much would his investment be worth at the end of the first year? Well, he invested 5 grand. And now, after tax, he gets to keep 90 euro of the interest that he earned, which means it's the 5 grand he invested plus the 90 euro in interest that he gets to keep after tax, which means at the end of year 1, the value of his investment is 5,090 euro. If that's the value of his investment at the end of year 1, that would be the value of his investment at the very start of year 2. So Aidan calculates that after tax, his investment will be worth 5,196 euro and 89 cent at the end of the second year. So that's F at the end of the second year. Calculate the rate of interest for the second year. Okay. This is the principal amount that he has saved going into the second year at the very start. So that's his value for P. Okay. But because there's tax involved in the question, I can't use the compound interest formula to find out what the interest rate is, because the interest rate is going to be adjusted based on the tax calculation. So how we answer this one is, at the end of the second year, that is the value of his investment, 5,196 euro and 89 cent. But it was originally worth 5,090 euro at the beginning of the second year. So if we subtract one from the other, that'll tell me how much interest he earned for that year, as in how much interest did he get to take home. That's his interest after the tax had already been deducted, because it said his value of his investment at the end of the second year was this figure, okay? And that was after the tax had already been deducted. So that's why we have to do it this way instead, okay? So that figure is already after being, that figure already incorporates the tax that was removed from it, which means the figure would have been a lot higher if there was no tax to be paid at all. Now, if the tax is 40%, so they would have already removed 40% of the original interest amount, and then he was left with this figure. That means this figure is equivalent to the 60% that remains. The question is asking me to calculate the rate of interest. Well, in order to calculate the rate of interest, I need to know how much interest was earned in total before the tax. So I set up an equation. The 106 euro and 89 cent must be equivalent to the remaining amount of interest he got to keep. So that's 60%. 100% take 40% for the tax, leaves me with 60%. Set up that equation. Once you know what 60% is, divide both sides by 60 to get what 1% is. And then once you have 1%, you can get any percentage after that by multiplying. So turn 1% into 100% by multiplying both sides by 100, which now tells me that the full 100%, which means the full amount of interest that he earned before any tax was deducted, is €178.15. I now want to express the interest amount as a percentage of the investment amount at the start of year 2, because we have to do it separately for year 2. So this is the interest amount. I want to express that as a percentage of the amount he invested at the start of year 2. The amount he invested at the start of year 2 was what he ended up with at the end of year 1. So that's €5,090. So I'm over here. The interest amount was €178.15 all over. The amount he invested at the start of year 2 was €5,090. Multiply that by 100 to turn it into a percentage, and you get 3.5%. So that's how much interest he would have earned before the tax in order for him to take home €5,196.89 at the end of the second year. Now you can obviously check if that's correct, because I didn't have to round that figure, that's exact. Okay, so I'll just show how I check. Okay, so for year 2, now that's the compound interest formula subbed into, but you could just do this instead. So this is the value of his investment at the very start of year 2, because it came from the end of year 1. If I'm saying the interest rate for year 2 is 3.5%, get 3.5% of his investment. That gives me €178.15, which is the interest that he earned. He didn't get to keep all of that interest because the government taxed him. Get 40% of that figure, which is €71.26, and then remove the tax from the interest to see how much tax did he actually get to keep. That was €106.89. And that is the exact difference between the amount of his investment at the beginning of the year and the amount that they said he got to take home at the end of that year, which was €5,196.89. So the difference between those two figures was the €106.89. So I now know that my interest rate for year 2 prior to tax is correct. You could do it another way, all right? If you know what the interest rate is, I'll just give an example, right? If you know the interest rate for any particular year was 5%, but the government is going to tax 40% of that. So 40% goes to the government, you'll get to keep the other 60% of that figure. You could just get 60% of the interest rate, and that would give you the interest rate after tax. So 60% of 5, so 5 multiplied by 60% will give you 3%. So after tax, the interest rate that you'd actually get to keep would be 3%, and you could just work with that figure instead. Okay? Government gets 40%, you get to keep the other 60% of your interest. So you could work with that way, and then you could just use 3% inside in your, your compound interest formula. Just a very quick example then on dirt tax, just to add into your notes. So an investment of money earned compound interest of €53.60 after dirt tax of 33% was applied. How much interest was earned before tax? So if 33% tax has already been applied, that means they have already removed 33% from the interest that you had originally earned, and they left you with the other 67%. Okay? So the dirt tax, if it's 33% dirt tax, the government takes 33% and you get to keep the other 67% of the interest that you earned. So if you got to keep €53.60, because they said that was the amount of interest after tax had been applied, then you got to keep 67%. So that means the €53.60 is equivalent to 67%. So I can set up that equation. The question said how much interest was earned before the tax was applied. That means find 100%. Okay, so get what 1% is first by dividing both sides of the equation by 67. So therefore 1% will equal 80 cents. And now I want to get what 100% is. So multiply both sides by 100 afterwards and you'll get 100%. So the full 100%, €80, that would have been the interest that you earned before any tax was deducted from it. I can check if that's correct. So if I earned €80 in interest over, we'll say, it doesn't matter how long the period of time was, we'll say over 1 year, but the government took 33% from it and left you with 67%. If you get 67% of €80, that works out to be €53.60, which is what they said it was after tax, so I'm correct.